Hello guys, welcome to the second example of writing the equations of polynomial functions. So let's go ahead and just jump right into this one. What we need to do is find our zeros. So I'm going to start again with my zeros, my x-intercepts, my roots, my solutions. Again, all those words are similar, they're exactly the same thing. So here, my first zero, where it crosses the x-axis, here's my x-axis, it crosses at 0, so my first zero is x equals 0. My second zero, where it crosses the x-axis, is 6, x equals 6. And my third zero is x equals 8. All right, so we have 3 zeros in this one. Again, we don't know if we have complex roots. It does not give us more information, so we're just going to assume that it has 3 real zeros for our purposes. Just kind of keep that in mind. So we got to find our factors now. We have to find our factors. And this is where my students start getting confused when we have this x equals 0. So I'm going to skip that for just a second, and I'm going to do x equals 6. Again, so if this is positive 6, what made it 0? Well, if I had an x minus 6 equals 0. So my second factor is x minus 6. Here it would be x minus 8. So I got x minus 6 and x minus 8. Now, let's think about the one that's a little bit more complex. X equals 0. Well, if I do this, I have x minus 0, right, is a factor. But do I really need that 0 there? No, because it's 0. So what does that come out as? What's that factor? It's just x, because you don't need to include the 0. So for this one, we're going to multiply and then find what our possible polynomial is. Again, we say possible because it's only an approximation based on the zeros. You can multiply these two first, or you can multiply this one into this one. It doesn't really matter. I don't think one method is easier than the other. So I'm just going to go ahead and distribute this x times x is x squared. And then x times 6 is negative 6x. And notice that I do not distribute to this one because you only multiply it once. If you multiply it into the second binomial, you're going to multiply that x twice and you only have it once. So just multiply into the first one like that. And then we have x minus 8. And now we got to multiply this. It's a 2 by 2. So I'm going to use the box method again with a 2 by 2. I'm going to put my x squared here, my negative 6x, my x, and my negative 8. So notice I have some negatives on this one, and I have different degrees or exponents. Actually, not degrees, exponents. So we're going to have x to the second times x. That's x to the third. Here I have a negative 6 times a 1, which is just negative 6. X times x is x to the second. And then we have x to the second times negative 8 is negative 8x to the second. Then we have negative 6x times negative 8x is positive, because a negative times a negative is a positive. 6 times 8 is 48x. And notice that this one actually did not have a constant, because all of these have x's. So let's put it all together. We have x to the third. We have negative 6x squared and negative 8x squared, which is negative 14x squared. And then we have positive 48x. All right, so this is the polynomial that we get. For this one, the y-intercept, because there's no constant at the end, is 0. And if you look at the graph, here it is at 0. So this one actually might be the answer for this one. We are not too sure. But just to cover our basis, I'm going to put a letter A, because A was our GCF in the last example. Note that it could be 1, because we don't know. We're not giving that much information. But I'm going to put that GCF of 1 because if there's a GCF, it factors out and it doesn't tell us a 0. And then I'm going to put the answer, x to the third minus 14x squared plus 48x. All right, so there is my equation for the function based on the fact that I don't know if this is the exact equation. I think it is though, because the y-intercept is at 0 and this one does not have a y-intercept, but that's how we did that one. All right, let's go ahead and try a third example. Let's go ahead and try a third example. So we're going to find the zeros. This one's -8. X equals -8. This one is x equals 1. And this one is x equals 8. All right, so I found my zeros. Now based on finding my zeros, I'm going to find my factors. If this is x minus 8, my factor is x plus 8. If this is x equals 1, then my factor is x minus 1. If this is x equals 8, then my factor is x minus 8. Now, I want to show you that there's a strategy to multiply this, which is going to make our lives a little easier. I have an x plus 8 and an x minus 8. I'm going to multiply those two first because one is positive and the other one is negative. Does it matter? No, it does not matter. You could have multiplied these two together, it wouldn't have mattered. Or you could have multiplied these two together. But watch what's going to happen when I multiply the positive and the -8 together. Again, it's just a strategy in math. You can have done it any way you'd like. So I'm going to multiply that using the box method. X positive 8, x minus 8. So we're going to have x squared, 8x, negative 8x, negative 64. And this is why I chose to do that strategy, because what happens to this 8x and this negative 8x? It cancels out. So when I simplify this expression, x squared minus 64, it turns out to be a binomial. And it makes my life just a little bit easier when I multiply it by the x minus 1. It's just going to make my life slightly easier because now we have a binomial times a binomial. 2 terms by 2 terms. And to solve this one, I would just use the box again. And notice that I don't have to do a really long box like we did in the first example. So this is x squared, negative 64, x and negative 1. Make sure you don't forget the negatives. X to the second times x is x to the third. Negative 64, x squared times negative x squared. And then a negative times a negative is a positive, like that. So if we look at this, we're going to have x to the third, negative 1x squared, negative 64x, and positive 64. Notice that none of them combined because this was x to the third, this was x to the second, this was just x, and this was just a constant. So here's my answer. Now, is this the correct equation? Well, let's look at the y-intercept. The y-intercept is 64. Therefore, the graph should be crossing the x-axis way up here at 64, but it's not. It's actually down here, right in the middle. That implies that we have a GCF. That implies that we have a GCF. So my answer is going to be the polynomial equals some number that was taken out, that we can't see, that we don't know, times x to the third minus x squared minus 64x plus 64, like that. So that would be your answer because of the GCF that we multiply. You could find it, but that's more work, and I'm just kind of trying to get the general idea in there for you guys. All right, hopefully this video helped. Give me a like and let me know if you have any questions. Have a good day.